Thrust means what? So in a fluid, in a non-viscous fluid, I have taken a body of volume, some volume is VB, let us consider. So now this density is density of the substance, and then here density of the liquid, whatever we have considered. Now in that, what happens, whenever you are taking the same body from the air to water, at that time what happens, nothing but its apparent weight will decreases. What is the reason why it will decreases? Means due to the upthrust. Upthrust nothing but an upward force will be exerted by the fluid in whichever we are just sinking the body. Any body, if you are keeping inside of a fluid, nothing but at that time there will be an upthrust on the body. In which direction? That will be in the upward direction. That will makes the weight of the body will become less. Why? Because weight will be acting in which direction? Downward direction. Now upthrust is acting in the upward direction. That upthrust is known as what? Force of buoyancy. That upthrust is acting in the upward direction. Obviously weight is acting in which direction? mg. See, for mg some opposite force is there, means here weight will decreases. That decrease in the weight is known as what? Apparent weight. And then this upward force is known as the upthrust or force of buoyancy. I said the Archimedes statement for the force of buoyancy. What is the force of buoyancy or upthrust here? Fb is equals to, force of buoyancy is equals to, what is the formula? V rho g. V rho g is the general formula, but here you have to take everything properly. That is, what you have to take here? Volume of the substance whichever we are just submerging, volume of the substance, and then this is our density of liquid, and then G you have to take. The volume of the substance whichever you are just dipping in the water, otherwise submerging in the water, the volume of the substance, and then density of the fluid in whichever you are submerging the body, and then into G. That is a force of buoyancy formula. And also we have seen the apparent weight formula also. The apparent weight nothing but, what is the general formula? Basic formula is what? The actual weight minus upthrust only. Actual weight is there in which direction? Downward direction. Minus upthrust gives you the apparent weight of the body. Why? Because the apparent weight also will act in which direction? Downward direction only. This is the apparent weight. That apparent weight is equals to the actual weight minus force of buoyancy. So the actual weight is how much here? mg minus force of buoyancy is how much? The volume of the substance, density of the liquid, and then G we got. Now this is belongs to which one? Weight is purely belongs to which one? Substance only, right? Dipped body only, that is just belongs to. So that what I can write in the place of mass, I can write that volume of the substance and then density of the substance. Why? Because this mass is purely the mass of the substance only. So that Vs into rho s into G minus Vs into rho L into G. Then what I can take common here? Vs G, even then I will take it as rho s also common only. Then what is remaining for us? 1 minus rho L by rho s. This is the apparent weight, and then this apparent weight is equals to, this is nothing but what? Actual weight only, that is the actual weight W 1 minus rho L by rho s. This is what we have discussed yesterday about the what force of buoyancy and all, and we have discussed so many things about the Pascal law. What Pascal law states? Pressure will be distributed equally, that's it. Whatever the pressure we are giving from outside, that will distribute equally. Whenever you are increasing the depth, then what happens? Pressure will increases. What is the, whenever the container is open, at that time what is the formula for us? P is equals to P naught into rho g h we will get. Whenever the container is closed, at that time only what will get? Rho g h only. And also in that mainly I have said some points that whenever the points are at the same level, then what happens? They will have the same pressure irrespective of the shape and then size of the vessel, irrespective of the weight of the liquid which is there above that point. That is, everything is not necessary, only the height you have to consider. Then the points which are at the same level will have the same pressure, that is rho g h only we will get. And after that, before that I said one more point. At any one point, if you see the pressure, that might be anywhere in the fluid, the pressure will be same from all the directions. From all the from the bottom to top, otherwise top to bottom, everywhere pressure will be same only. That is about the first point. And then next point we have discussed that is independent of shape and size. It will purely depends on what? height only, that is everywhere that might be, but at the same level they will have the same pressure. And after that what we got? I think hydraulic lift and then Pascal's law and all. What is the hydraulic lift says? F1 by A1 is equals to F2 by A2. And after that we have seen that U-tube problems also. In that U-shaped tube problems, what happens? We have just considered the main logic in that problems is at the interface you have to consider the point. Wherever the interface is there, that might be anything, alcohol, oil, anything they will mix, glycerin and then water. Most of the cases they will give the glycerin and then water only. So, glycerin and water or oil and then water. Why? Because we cannot mix them together. So, that only here, for example, glycerin water they have given nothing but you have to consider the point in one side of the glycerin water interface, you have to consider exactly just below the interface. Ramesh, good morning Ramesh. Good morning. Idara class alle. So here what happens means exactly at the interface you have to consider the point. On the other side you have to consider the point at the same level. Then what you have to do? Nothing but you have to apply the equal pressures, that's it. At equal levels the pressure will be obviously equal only. Then you will get the density there. Why? Because obviously the U-tube will be open to the atmosphere. P0 plus rho g H1 is equals to rho 1 g H1 is equals to P0 plus rho 2 g H2, that's it. So here the thing is, instead of taking P0 and all, instead of writing that much of equations and all, you just remember that rho 1 H1 is equals to rho 2 H2. If you take, then you will get the answer. Why? Because everything gets cancelled obviously. P0 gets cancelled, G gets cancelled. What will be remaining? Only rho and then H only will be remaining. So rho of the oil you want nothing but then rho 1 H1 by H2. If you want height means rho 1 H1 by rho 2. Like that you can find out the U-tube problems also. And we have discussed the hydraulic lift and all. In that we have seen some problems. After that we have discussed the force of buoyancy. So force of buoyancy mainly states that an upward force will be acting on the body whichever submerged in the fluid. Here in this case, next case what we will see nothing but that submerged partially na, completely na, otherwise just below the water surface. The three cases will be there. Those are very important and then very confucius. So I will explain you that clearly. So that is about the next case. But here the apparent weight of the body will decreases. What is the reason? Why it is decreasing? For opposite to the weight there is an extra force, that is a buoyancy force. Due to that obviously this mg will get decreased only. So due to that the apparent weight will be there. The apparent weight value will be W minus some value we are doing here. So that will obviously decreases. So based on this values only, based on this rho s and then rho l values only, we will have three conditions in this. Listen properly. And also always remember, Prajwal, okay? You want to go out and then come. Don't cough, what is that? Loudly. Why? Because they will fly off. ಏನು ಹಾಲು ಪ್ಯಾಕೆಟ್ ತಗೊಂಬಂದಿದ್ದ ಮನೆಯಲ್ಲಿ ತಗೊಂಬಂದಿದ್ದ ಇಲ್ಲ ಹಾಲು ಪ್ಯಾಕೆಟ್ ತಗೊಂಬಂದಿಲ್ಲ ಅದಕ್ಕೇ ನಿಮ್ಮಮ್ಮ ಬೈತಾ ಇದ್ರು ಅದಕ್ಕೇ ಕಾಫ್ ಬಂತು ಇವಾಗ. ಸೊ ಎಫ್ ಬಿ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಫೋರ್ಸ್ ಆಫ್ buoyancy formula is generally like virodhi. Virodhi means what? Virodhi means shatru, correct? Virodhi, like Virodhi only you have to remember it as Viroji. Arey, you go and come re, you go out and then come, relax. ಪಾಪ ಶ್ರೇಯಸ್ಗೆ ತಡ್ಕೊಳಕ್ಕೆ ಆಗ್ತಾ ಇಲ್ಲ. ಅಷ್ಟು ಅವಿನಾಭಾವ ಸಂಬಂಧ ಇಬ್ಬರಿಗೆ. ಏನು ಸಂಬಂಧ? ನೀವೇನೋ ಸಂಬಂಧವನ್ನ ಹೇಳ್ತಾ ಇದ್ರು. ಫ್ರೆಂಡ್ಶಿಪ್ಪಾ ಏನೋ ಮತ್ತೆ ಆ ಜೊತೆನೇ ಏನೋ ಮತ್ತೆ ಏನೋ ಸಂಬಂಧ ಬರ್ತೇನೋ ಏನು. So here the main thing is what we were discussing about. Yes, Virodhi. Virodhi, you have to remember it as Virodhi, that's it, okay na? Viroji. And volume of substance, density of fluid and then G, that's it, okay? So FB is equals to Virodhi, the formula. Now in this three conditions will be there that we call as even law of flotation, otherwise flotation conditions. For that mainly you have to consider the apparent weight equation only. In that you have to observe the densities. So if the density of substance is less than the density of fluid, then what happens? Density of substance, what happens to the body, where it will be, that is what I am asking. It will floats. Density of substance nothing but I am saying that I have taken a plastic ball. I have taken a plastic ball and then I am just dipping in the water and then I just pressed it, and then after that what I am doing nothing but I am just leaving it. Whenever I leave, immediately what happens? It will come up. Whenever I am pressing also, at that time it is applying some force on my hand. That force only upthrust here, Buoyant's force. So whenever I leave it, then what happens? Immediately it will floats up. So it will floats up. Why? Nothing but it will floats up until the weight of the body is equals to upthrust. It should be in equilibrium obviously. Why it is coming up? What is the reason? Our forces are in equilibrium. Before coming up, are they in equilibrium? Mg is less, right? Obviously. The weight of the body is less than the upthrust. So less than nothing but the forces are not balanced. Until it balances, body will move obviously. Whenever I have more force in this side and then less force in this side, I will move this side only obviously. When I will be in rest nothing but whenever I have both the sides same forces. So in the same way, until the weight of the body is equals to the upthrust, the body will be coming up only, still coming up only. For example, you are taking more deeper and then deeper. At that time what happens? Nothing but it will not stop in the middle. What happens? It will come up and then stop. Whenever it is coming up nothing but here on the surface, if I consider, the body will be there like this. The body will be there like this. Partially submerged, we call this as. Body will be there like this. Why it is a little bit inside? Nothing but because mg is acting. Obviously it is having some mg. Due to that mg, at this point exactly what happening? Nothing but the mg is equals to the force of buoyancy. And before that what happening? Whenever the body is there here, whenever I pressed here, at that time what happening? There is more force of buoyancy than mg. So here force of buoyancy, here force of buoyancy is very much high as compared to the mg. So only mg is smaller and then force of buoyancy larger. So whichever the side more force is there, the body will move obviously in that side only. So here force of buoyancy is large, so only body is going up. And finally on the surface it is coming into the rest. Why? Because both the forces are balanced. That is what, that state only we call it as equilibrium state, right? So here mg, on body which forces are acting? Only two forces. One is mg, another is force of buoyancy. Both are balancing, then only it will be in rest. Otherwise what happens? Nothing but it will flow, it will fly off like that only. Understand or not? So here whenever the density of substance is less than the density of liquid, whatever we consider, at that time what happens? Nothing but the body will be partially submerged on the surface, on the free surface of the fluid. Clear, right? You understand that? Then up to when it will be floating? Nothing but up to when it will be moving? Nothing but up to the weight is equals to exactly equals to the force of buoyancy. The body will be trying to come to the upward direction onto the surface. Whenever both are balances with each other, at that time exactly it will come onto the surface. If it is having very less density means, then what happens? Very less density than liquid means at that time what happens? Completely it will floats. It will floats completely like this completely it will floats. Because it is having less density only, but instead of taking plastic ball, I have taken the rubber ball. So that rubber ball, what it will do? Nothing but it will floats little bit. It will be submerged little bit. As compared to the plastic, rubber is obviously lighter only. For example, if you take rubber and then balloon, if you take, whenever you are just submerging the balloon and then you are leaving, then what happens? It will completely come up, otherwise it will be submerged partially. Completely it will be floated. Why? Because the weight is very less, density is very less as compared to the liquid density. Instead of balloon, I have taken a rubber ball. At that time what happens? Nothing but rubber ball will be floating only, but not completely, submerged partially. Why? Because its weight is appreciable value. As compared to the force of buoyancy, its weight is appreciable value. So that what happens? Nothing but the force of buoyancy will be balanced with the mg of the rubber ball. If you take the balloon only directly, balloon will have very less weight. So our force of buoyancy also very less only whenever it is coming onto the surface. So both are balancing with each other on the surface. The main thing is you can even either you can understand very clearly in the case of rubber ball and then balloon only. Why balloon is completely floating? Nothing but the weight is very less. Because the weight is very less, our force of buoyancy, what I said, it will be balances, right? So force of buoyancy also less. Why? Because both are balancing exactly on the top of the surface. Whenever you take the rubber ball will have some weight. So due to that weight, what happens? Nothing but it will be submerged partially on the free surface of the water. That is about the first case, whenever the density of substance is less than the density of the fluid. So what happens means, immediately you have to mainly think that whenever the density is less means obviously it will come up only, but we don't know that it will completely float, otherwise half will be submerged, otherwise 3/4 will be submerged. In any case is possible. For example, if we take the wood cannot float completely, so it will be submerged. We cannot tell how much percentage ratio it is submerged. Even the ice also, ice will not completely float, it will be submerged little bit. So that only the ice also, how much fraction of the volume it is submerged and all, we will find out the next problem only. So that is how you have to mainly identify that the density of the substance is less than the density of fluid means obviously it will floats only. But that flotation is completely submerged, otherwise half submerged, otherwise any percentage submerged, otherwise completely floating. That is just depends on the values whatever they have given. Clear? This is about the first density condition. Next condition is, second case is, whenever the density of the substance is exactly equals to density of the fluid, then what happens? What happens? It is not less than, right? It is less than means it will come up. It is greater than means what happens? It will go down actually. Density of substance is greater than the liquid means what happens? It will sink. For example, if you take the iron ball, at that time what happens? It will sink. There is no choice. If you take the plastic ball, at that time it will floats. If you take any wooden block like that, at that time in some cases that wood density, it will purely depends on the wood density and then liquid density. What happens means the body will be floating just below the free surface. Why? What is the reason? Nothing but if you see here, if you see in this next formula, what we will write here, Vs and then G, if I take common, what is remaining? Rho S minus rho L is remaining. So rho S is equals to rho L, nothing but what I can say, this one is 0. Then apparent weight is becoming as how much? 0. 0 apparent weight, nothing but it is not even floating, it is not even sinking, it is not even going to the bottom, it is not even coming to the top surface. So what happening? Nothing but it is just completely submerged just below the free surface of the water. That is the case you have to mainly remember whenever the density of substance is exactly equals to the density of the fluid, whatever we have taken inside. Next case is whenever density of substance is greater than the density of the fluid, at that time what happens? Body is having more density than the fluid, sinks, right? If I take the iron ball, otherwise copper ball in the water density is very much less as compared to the copper density. So that what happens? Nothing but the body will completely sinks at the bottom. This is what will happen whenever the rho S is much greater than rho L. See here, rho S greater than rho L, nothing but this denominator is greater than the numerator, nothing but can I say this value is negligible? See that here rho S is equals to rho L by rho S. This rho S value is greater than the rho L. Denominator is increasing means, for example, this is 1 by 100, let us consider. Can I neglect this one in front of 1? Then what happening? Apparent weight is equals to exactly W only. In the first case what happening? Nothing but rho S only less than the rho L. Rho S is less than the rho L, nothing but W minus some value we are getting. W minus some value, nothing but the apparent weight is decreasing. As the apparent weight decreases, then body will floats. Here in the second case what happening? Nothing but the apparent weight only not there. Nothing but not mg is dominating, not even fb is dominating. Force of buoyancy is dominating means it will come up. Mg is dominating means it will go down. Both are equal, nothing but what happens? It will be in equilibrium exactly just below the surface, free surface. This is important case. And also next, whenever you see here rho S is less than rho L, nothing but the mg of the body is less than the fb. Mg is less than, nothing but weight of the body is less than the opposite force means what happens? Body will come up only obviously. Why? Because mg is dominating in front of the fb here. Mg is getting dominated in front of the fb. So that fb is dominating in which direction? Upward direction. So only the body will go in upward direction. In this case, if I say rho S greater than rho L, nothing but substance is having more weight as compared to the fluid upthrust. So weight is greater than the upthrust, nothing but mg is there downwards, that is dominating. So only body will come in downward direction. Whichever is dominating, along with that it will go. In first case, which is dominating here? Upthrust is dominating, so that only body will go up. In third case, who is dominating? Mg is dominating, so only it will go down. In second case, what happening? Neither mg is dominating nor upthrust is dominating, so that the body will be in equilibrium just below the free surface of the water. Clear? That is about the loss of flotation. Right, that flotation conditions. Flotation conditions. Flotation conditions. In that first one, density of substance. ಸ್ವಲ್ಪ ಹಾಕ್ಕೊಂಡು ಬಾ, ಸ್ವಲ್ಪನೇ ಹಾಕ್ಕೊಂಡು ಬಾ. Density of substance is less than density of fluid. Substance is less than fluid. As the upthrust is more, as compared to the mg, body either partially submerged or nearly floating until the force of buoyancy and mg balances with each other. Next, second case, rho s is equals to rho l. When substance density and fluid density are same, then apparent weight is 0. Then body just submerged below the free surface. When density of third case, density of substance greater than density of fluid. As the weight of the body is more than the upthrust, body sinks completely. Just copy that. The apparent weight now the lift is going in the upward direction with acceleration a. First of all, tell me what forces are acting on this body which is submerged. Mg is acting in the downward direction, then upthrust is acting, right? Upthrust is acting in the upward direction. Now Ma is there, that's it, no other forces. Now you have to write the equation, means what I can write here? Ma is equals to what I can write? Fb minus mg. For acceleration Fb is supporting, so only Fb minus mg will get. So that you have to find out the force of buoyancy, that upthrust only will give you the value of the apparent weight, So otherwise upthrust only you can write this one as, then what will you get here? MA plus MG. Then M common A plus G. Nothing but already you know that whenever the lift is moving in the upward direction, at that time what happens? Apparent weight will increases. Apparent weight is increasing, nothing but here we are calculating the upthrust. So that upthrust is FB is equals to M into A plus G. For example, the lift is going in the downward direction. At that time FB is equals to what will you get? Tell me. M into G minus A will get. At that time upthrust will be decreases. Whenever the lift is going up, at that time upthrust is increasing. Whenever the lift is coming down, at that time upthrust is decreasing. Whenever the lift is falling freely with A is equals to G, at that time what happens? Force of buoyancy will become how much? 0. Why? Because the body is completely falling freely, nothing but there is no upthrust, nothing. So FB is equals to how much you will get? 0 only. If the lift is moving in the upward direction with acceleration G, then what happens? Up downwards with G, nothing but FB is equals to M into G minus G will get, then you will get it as 0. For example, if it is going upward, nothing but A plus G, that is G plus G, then what will you get here? FB is equals to 2mg, nothing but the upthrust will be 2 times than the weight. At that time what happens? Body will floats or sinks in this case. FB nothing but which force? Upthrust. Upthrust is double the mg, nothing but what happens? It will floats. Here in this case what happens? Just submerged just below the surface, free surface. Why? Because the apparent weight is becoming as 0 obviously. Then here what happens? Nothing but it will sinks, correct? Mg minus sinks, yes, sinks. So here it will be floating, we don't know what values, based on the values only it will be floated completely, otherwise submerged we will find out. Clear? This is about the force of buoyancy when in the lift. You have to calculate the force of buoyancy in the lift, nothing but this is FB. Force of buoyancy in the lift, that is whenever the lift is moving in the upward direction with acceleration A, and then on this body which is submerged in the water, that will have mg and then force of buoyancy as the forces. Now always you have to write the equation for ma only, like mechanics. So m into a is equals to y, because this is not in equilibrium, this is moving obviously, accelerating frame we have to take. So that accelerating frame nothing but we are there of course inside only, so only pseudo force will not act. Again you don't go for the pseudo force concept and all. So here ma is equals to what I can write? Fb minus mg. So that Fb is equals to what I can write? Ma plus mg, then weight of the body is increasing here, mg plus some value we are taking here. Then next case is whenever the lift is going in the downward direction, at that time A is there in the downward direction, mg is there in the downward direction, Fb is there in the upward direction. Again ma is equals to, for acceleration who is supporting here? mg minus Fb. Then Fb is equals to mg minus ma we will get, then m common g minus a, nothing but here weight is decreasing, mg minus some value you are removing, then at that time weight is decreasing. Next, whenever the lift is falling exactly at acceleration is equals to the g value, at that time this case only you have to take, again this is coming downwards, right? So that m into g minus a value is how much? G, then force of buoyancy will become how much? 0. There is no force of buoyancy whenever the lift is falling freely. Even whenever the lift is falling freely, what is the normal reaction? Normal reaction also 0 only, I said you will be floating in the lift. Then next one is whenever the lift is going with acceleration g, this is lift is going upward case, at that time ma in a plus g, then in the place of a I can get it as g, then mg plus mg will be 2mg it will be, then the force of buoyancy will be double the weight of the body. Clear? At that time body will purely sinks or purely floats, I'm sorry. Copy that all the cases. Force of buoyancy in a lift. Yes. Until when? Until when? The force of buoyancy is exactly equals to the weight of the body. I said mg and then fb should be balanced with each other, until then it will be coming up only. So whenever it is coming onto the surface, otherwise submerged partially, whatever it might be, always it is sinking also, at that time what happens, nothing but mg will be equals to fb only, that might be sinking or floating, anything might be happening. So always the weight will be equals to the force of buoyancy. Until then what happens, the body will be keep on moving only. So here what happens means the mg is equals to fb. What is the m here? Mass of which one? Substance. Always mass of the substance only. Force of buoyancy, what is the formula I said? V rho g. Here what is that? Volume of the immersed body, volume immersed, and then rho is what? Density of the liquid, and then into g. Then this mass nothing but what? Volume and then density into g of the ice cube, whatever we have considered. Here this is the total volume, this is the immersed volume. That is the difference between them. Already force of buoyancy nothing but what? Whenever it is there inside of the water, then only it will act. So it is immersed, how much we don't know. So that immersed volume only, I said that force of buoyancy formula is what? What is the force of buoyancy statement? Archimedes statement is what? V rho g only, but what we say, the weight of the submerged body is equals to the volume of the displaced fluid only. So here weight of the submerged body you have to take, the upthrust is nothing but weight of the submerged, only submerged. This is not completely submerged, the ice is not completely sinked in the water, that was floating, a part of ice is there inside. How much part is there? Nothing but Vi is there, that is what you are going to find, how much it is submerged. So that here volume of the ice, that is V by Vi I will take. Why? Because I want to find out that fraction only. For that I will get the ratio first. Then what happens here? G gets cancelled. Then rho of the liquid by rho of the ice. Rho of the ice. Rho of the liquid is how much they said? 1000 is the water density, and then ice density is how much? 900. 900 is the ice density. Then 10 by 9 is the here V by Vi. But you have to find out the fraction, means what you have to do? Delta V by V only, now you have to find out. Delta V by Vi only. Otherwise what I can say? 1 minus V by Vi. If you do 1 minus V by Vi also, the same thing only you will get here. Delta V by Vi only. So fraction nothing but what? Change in the volume by original volume only you have to find out. So that here delta V by Vi, or it can be 1 minus V by Vi, anything is same only. 1 minus 10 by 9, how much you will get here? 0.1. Correct? V by Vi minus 1. Initial volume minus final volume divided by initial volume, right? You will get. This is the submerged. No, Vi minus V by Vi you will get. Nothing but 1 minus V by Vi. 1 minus V by Vi only. But here, why we are getting here minus 0.1? That is submerged already. Inside it is there. So only you will get as it is loosed. Fraction nothing but what you will take? How much lost? How much change is there you have to find out. So that how much lost? Nothing but 0.1 is lost inside of the water. Inside of the water it is submerged, that is 0.1. Always you have to find out the ratio of volumes V by Vi, and then for that you just do 1 minus, that's it. Correct? You are not getting the answer. 9 by 10 reverse ಅಲ್ಲಿ find out ಮಾಡಿದ್ರೆ ನಾನು ಯಾವುದು ಇಲ್ಲ wait, actually our formula ಏನು? The fraction nothing but what is the formula? Delta V by V only, right? Delta V nothing but what is the formula you will get? V final minus V initial by V initial. But in case of fraction, in the kinetic energy, in the collision concept, I said that what to take loss nothing but we have to compare with the initial value, no final value, no initial value only. Initial minus final only, no you will do. So only what will get here? Nothing but however you can get, how much you lose, how much is remaining, it will come. So that V initial minus V final by V initial, out of the total value how much you are losing. So this initial indicates the total volume, this final indicates what? Immersed volume. So that here in the place of Vs, you don't confuse in between them. Here this is the V initial and then this is the V final, this is the initial and then this is final. This I indicates what? What is that? I indicates immersed or submerged, anything you can take. So only yesterday I have taken it as Vs or VB I have taken, I think so. So that only here this is immersed inside of the fluid. At that time this V initial is how much, total volume is how much, V minus final is what, immersed only you have to find out, Vi divided by V initial is how much again, V only, right? So that is V only. Now 1 minus Vi by V you have to get, 1 minus V by Vi is 10 by 9 and then Vi by V is how much, 9 by 10 will get, 9 by 10. Then what will get here, 10 minus 9 by 10 nothing but 0.1. That is a percentage of the volume it is immersed in the fluid. Listen again. So always you have to find out the immersed volumes and all means, first of all you have to balance the forces, that is force of buoyancy is exactly equals to mg. So mg is nothing but total, that might be submerged or that might be floating or that might be sinked. Anything you have to take that as mg, nothing but total weight of the body. Total weight of the body nothing but you have to consider the total volume and then total density of the substance whichever we are considering here. So that total volume is V and that substance density is how much here, ice we are taking, so that rho s we have taken, that is equals to force of buoyancy indicates what, only the upthrust nothing but the immersed volume, just immersed volume or submerged volume into the rho of the liquid and then into G, that is what it will indicate, that force of buoyancy nothing but the volume of submerged part and then the density of the liquid and then the G. Here it might be anything, submerged or S, or it might be I, anything, immersed, I nothing but immersed, S means submerged, anything is same only. Now here I want to find out the fraction first of all, for that I will find out the ratio as compared to the initial value, how much it is submerged we have to find out. For that I have just cancelled everything, after substituting I got V by Vi is equals to 10 by 9. Then you have to find out the fraction nothing but, always it might be fraction of energy means delta energy, delta change in the energy by original energy, change in the volume by original volume, change in the velocity by original velocity, always fraction means that only. So that here change in the volume by original volume. Here change in volume nothing but you have to take initial to final. If you take final to initial, then what will get, nothing but how much is remaining you will get. By this how much you lost you will get, clear. So that here V initial minus V final by V initial you have to take. So initial is nothing but what, total volume, out of the total volume how much is immersed. Immersed volume is final volume and then initial volume is V only. So that V minus Vi by V, from that 1 minus Vi by V I can write, then Vi by V is equals to how much, 9 by 10. Then how much fraction is submerged inside, 0.1 fraction is submerged inside. How much is floating outside, 0.9 is floating outside, clear? Right, 0.1% of ice is submerged in of ice is submerged in and the remaining is outside, and the remaining is outside. Finished? Next write a problem. The tension in a string holding a solid, tension in a string holding a solid block below the surface of a liquid, as shown in the figure is T naught, as shown in the figure is T naught. When the system is at rest, what is it? The tension in the string holding a solid block below the surface of the liquid as shown in the figure is T naught. When the system is at rest, what will be the tension T? What will be the tension T in the string if the system has an upward acceleration? System has an upward acceleration. Yuraja, ಅಲ್ಲಿ ಹೋಗಿ ಅಸೈನ್ಮೆಂಟ್ಸ್ ತಗೊಂಬ. Find out the tension properly, find out. ಕೊಟ್ಟಿದ್ದೀರಾ ಆಲ್ರೆಡಿ? ಎಸ್, ಯು ಜಸ್ಟ್ ಕೀಪ್ ಡೂಯಿಂಗ್ ದಟ್ ಅಸೈನ್ಮೆಂಟ್ಸ್. ಐ ಆಮ್ ನಾಟ್